Hello, everyone. Whoa. And welcome to Capstone Presentation Day. I'd like to extend my thanks on behalf of all the Capstone teams to everyone in attendance and everyone else who has helped us along our way. I'm thrilled to announce our presentation first, cloud-based Auvik integration solution with Webex with our team. We are Advanced Bagel Networks. I'm Stephen Wolf, the project manager.
I am Luke Griffith, the lead networking engineer.
I'm Pete Carchi. I'm the technical writer and implementation engineer as well.
I'm Nathan Campbell. I am the cybersecurity engineer.
My name is Sander Solsvik. I am the system/network engineer, and I'm actually from Norway, and my family has come all the way from Norway just to see this.
On to a little bit about what we're going to be presenting on today. So we're going to touch on Auvik, as well as some use cases for our Webex bot. And then we're going to be going over the problem statement about why we need the bot. And then show you some proof of concept and live demonstration of the bot working and how to interact with it, as well as some concluding thoughts about technical challenges, as well as challenges we faced as a group. Now to hear a little bit about 3RT.
Right, we'd like to thank our sponsor, 3RT Networks. 3RT is a managed IT service provider out of the La Crosse area that provides custom IT solutions for all layers of your environment, from design to implementation. We'd also need to introduce you to Auvik. All right, so Auvik is a network management tool that 3RT uses to manage their clients' networks. The way you use it is that you upload a collector onto your network, and then it scans the network and uploads that information into the thick client that you can then use to manage your client's networks. It can also give you information about your devices through SNMP credentials, as well as give you alerts when your devices are offline, and you can remote into your devices through the thick client. Now Pete's going to quick talk about what we're going to be doing with Auvik.
Okay, so commercial software is expensive. You want to get the most out of it as possible. So 3RT has asked us basically to derive information from their Auvik client and the Auvik API that they pull down that's connected to the connectors and put it into a Webex chatbot. We're going to create a proof of concept for them, which is the chatbot you'll see in a bit, and would parallel any experience that 3RT is going to put into a production environment. So 3RT has asked us to provide them some things. Reduce the time to access their Auvik information via the bot, to centralize the use of Webex, which is their universal communication tool. This is like Slack or Teams, if you're familiar with those applications, to get more value out of Auvik, and then also more accessibility of their Auvik data, mostly being able to use it remotely as well. So next slide, please. Okay, so they've asked us to cloud host it. In this case, we used Azure. We'll talk about that a little bit later. And we've put this bot into Webex, right? They no longer need that thick client that Nathan was talking about. They don't have to scroll through all the devices. They don't have to take all that time. Instead, they ask the bot, hey, tell us about our servers. Tell us about our devices. The bot gives them the information back. Speed, very key. So we'll also be presenting a white paper for them at the end. They've gotten that already. And then the proof of concept environment as well.
All right, so what are the use cases 3RT will use this bot for? Well, it will increase the speed significantly from retrieving information from all of your devices, be it servers, switches, firewalls, routers, anything you have in there. You just go into the bot and you ask it for the device you want to get information from, and it pulls it immediately. It is a lot faster than actually logging into Auvik, as we will display later on. This chatbot is also able to get any information through the APIs that Auvik provide, such as APIs for alert, inventory, configurations, and statistics. Now let's talk software with Luke.
Sure, so here's some of the software that we're going to be using for our project. Webex, which is the tool that 3RT is using to communicate in their teams, see what everyone's doing. Auvik, which is their tool they're using to monitor client devices. It allows you to see many of the statistics on them. However, it can be a little bit slow to get in detail at everything. Even though it does have everything, it can be a bit slow to access. And then we're using Azure with Docker containers, and that allows us to host our platforms, so we're able to talk between Auvik and Webex, so they can send messages and see what's going on very quickly, and allow you to get an overview of the network. And then Python is the code we're using, and we wrote this in. Now let's talk about the hardware we're using.
All right, so we'd like to thank 3RT for lending us some hardware that we have used to simulate our sites for Auvik. So they have provided us with 2 firewalls, 2 switches, and a server. In addition to that equipment, we have borrowed some equipment from the CNIT lab. That includes 2 routers, 1 switch, 1 server, an access point, and a controller for that access point. Now, Luke, how are we using all of this equipment?
Sure thing. So we have this all laid out into 2 separate sites. Site Alpha, we have a direct connection to the Stout internet on our firewall. Then it goes to a router, then a multi-layer switch, then another switch, a Dell server that is hosting our Auvik collector to gather information on that network. Then we have another site, Site Bagel. It's completely separated from Site Alpha. Another firewall connected to the internet, router, switch, and server, once again hosting the Auvik collector. And the reason for this is we have 2 separate sites to allow us to prove that solution works over many different networks, completely separated, and with different devices as well. Now let's take a look at Auvik, and we're going to see that topology in Auvik. We'll be looking at Site Alpha. So first we're going to sign in here, and it does time out, and it's secure, so we're going to have to do a password, and we're going to do multi-factor authentication. So this is part of, you're seeing it takes a little bit of time to get going. It's not just, you're not just starting to chat in Webex or that sort of thing. So we got a door code. We got that. Now we're in once it loads, which should take a little bit, but then we'll see loading. And then, so see the cloud, that's the internet connection to our firewall. And then below that we have a router. And then in that little box there, we can see our switches. We can see that purple icon, that's Auvik, because that's actually our collector. We can see it in here as well. All your devices are in here. Now if we go into the switch to say, we can look in there, and now we get all this in more detail. But we have to go into each device to get this detail. And we get, the name of it, like the model of it, any names we have, uptime, get to see all the information we're getting from it, warranty information, what version of software is on it, online interfaces. We keep going down. We could send commands to it. And then we see all our interfaces in detail now. We have a list of which ones are offline, which ones are online. And then we have our utilization, bandwidth, all sorts of details on our devices available in Auvik, as well as our, we got a lot of storage use going on right now. But yeah, that's Auvik. Now let's see how our bot flows through everything and works.
So here's the flow chart kind of describing how you can interact with our WebEx bot. So first you enter the start command, and that'll wake up the bot. It then prompts you for the sites that you have access to. Once you enter a valid site, it then will prompt you for ESXi or Cisco. Entering ESXi will then display all the hypervisor information. And if you put in Cisco, it will give a brief overview of all the devices with a little bit of information about them. And then if you go past Cisco, it will then prompt you for interfaces or warranty, so you get some more specific information. Once you enter that command, it'll then list all the host names, and you will then paste that host name back into it, and it will then feed you that information on that specific data. So let's see that a little bit of the code that makes that possible.
All right, so the way we went about coding this bot is that we started with making API calls to Auvik in Python. Once we had that pretty well down, we then combined all of our functions into a bot that could talk to a user in a terminal. From there, we had our most challenging piece of code to write, which was getting the bot to talk to people in Auvik. This is actually an example of some of that code we're using. This function makes an API call to Webex, gets the history of the chat with the bot, and then if the user that sent a chat last in the chat was the user that we set it to, it will return that information, and the bot will be able to read it and respond to it. Now, if you want to go to the next slide. All right, and this is an example of one of our functions to make that API call to Auvik. So this makes the API call, gets back the JSON information, and then parses it and sends it to the WebEx user. Now we'll be actually doing a live demonstration of our bot in its final form.
All right, so now we'll be visualizing the flowchart that Stephen went through earlier to see how the bot actually operates in WebEx Teams. So we'll go into our Capstone site here, our alpha site. named Stout Capstone in Auvik. Then this will then go to the bot. The bot will revert back to ask you, do you want to view E6i or Cisco devices? So we'll take a look at E6i first. This will now go and query Auvik for all the information that relates to the E6i server in this site. So here we get the host name, we get the device type, it's a hypervisor, it's running VMware E6i 8, and it's an online server. We also get the serial number. How neat is that? So now let's take a look at our Cisco devices that are in our network. So it will then query Auvik again and get a list of all of our routers, switches, all devices that are registered in Auvik. So we get their host name, we get the device type, we get the version, everything you would need. And then we can go even further in and ask for the interface status and type of devices. So we'll take a look at our router here. So it works perfectly fine just copying the names to, sometimes you can have lengthy host names. And this will then go back into Auvik and get the information for the interfaces. So we can see we have Ethernet interfaces, that they're online, and our serial interfaces offline. Now we can also view the warranty, which is important for your devices. So it'll then ask you again, which device do you want to view the warranty for? So we'll go and view the warranty for our Alpha DC distribution switch. And this will then, again, call the API to Auvik and get the information it needs. Warranty information, service information. Now on our switch, it's expired back in 2021. But if we did have an active service status, we would also get a recommended software version to run on this switch if it's not up to date. So we can now go back through the menus and exit it and put the bot back to sleep. And then you can just issue the start command again once you need to ask the bot more information.
So you've just seen a proof of concept of essentially what used to take multiple clicks through devices, scrolls, to pull all this information down, now is broken down to a couple words, right? And it spits it all out, gives it all back to the engineers, accelerates their results, reduces labor costs, and allows them to effectively manage more devices with fewer people. With that, I believe we're going to talk about some of our technical challenges.
Yeah, so one of the first challenges we ran into was learning to use this new to us Auvik platform. We had to install collectors on our sites. We had to install credentials for all our devices, figure out how to get them in there, make sure they were all reporting back, make sure they were all doing everything, go through all the menus in Auvik, go through everything, see where it's all at, see how to use the APIs. But it's been really nice to use Auvik, and that it's worked really well.
Another technical challenge that we faced was we initially believed that we needed webhooks to communicate between our Azure and our bot, and that caused us a lot of problems trying to get that set up, and it wasn't working, but we were able to find out that we actually didn't need webhooks at all. We were able to call our APIs from within Azure and get the information that we needed to.
Right. We also ran into an issue when building the bot. We weren't getting the correct, we were getting error messages saying we did not have access to the Auvik API. So we went into Auvik's documentation and we found that there are specific roles within Auvik that a user has to have to be able to access the API calls. So we were able to call up 3RT and have them give us those credentials.
And then we did also have some issues early on in our project, setting up our site, getting connectivity. Specifically, our NAT was not working correctly, I first thought. After consulting with one of the 3RT engineers, firewall engineers, we worked with him. We got some configuration that should, in theory, work. It was very similar to what I had already put in, but sure, let's try it. So I tried it, and the same thing happened. We didn't have any results. None of our pings were going outside. And then I started digging into some more of the forums and documentation for these firewalls, and found that after turning on all the debugging features, I could see that the traffic was actually exiting our network, and it was going out and finding the addresses we were trying to ping. But when it was going back in, the firewall was actually denying a re-entry of the traffic, so it was just getting dropped at the interface. So after putting in an access list to allow that traffic back into the network, we were able to have internet connectivity so that we could launch our Auvik collector and get all that going.
And then our last technical challenge we had was working with Azure web hosting. It was new to us, a little difficult. We tried to do something with headless code, and instead we really figured out a containerized solution is far, far easier. So went the Docker route and got that working quite quickly afterwards. So let's talk a little bit about results and impact, right? So we've got a successful proof of concept of being able to use a mobile device if you wanted, using a web bot through Webex to pull data down. Your Auvik value of your software licenses is now worth more. You can do more with it. To point out, this was just a proof of concept. We did not comprehensively cover every single API that Auvik has. There is much more detail that 3RT will be able to access and be able to use this tool for. For us, the average cost was around $12.41 a month, so not brutally expensive. I think that will get larger as you scale up the amount of devices and licenses, obviously, but that is where we set off. And then lastly, labor savings, right? I mentioned this earlier, but there's more devices. There's always going to be more devices to do with fewer and fewer people. The automation is frankly the way of the future when it comes to all things IT. And this we hope will help 3RT. And lo and behold, if you can head to our new slide, 3RT actually let us know this is a live picture of the bot in their production environment. It feels really good as a college student to create a product that in 3 months all of a sudden is being used in industry. That doesn't happen often, not even at a professional level. Stuff lives in sub-prod forever. When it makes it to prod, feels good. So that's really nice. And then lastly, I think there was some discussion that they're going to take this bot and fold it into an existing bot that they already use. So I assume at some point we'll hear about the 3RT WebEx Superbot that will be making its rounds around Wisconsin. So with that, lastly, we're going to talk about some hours worked labor on our end, and I'm going to hand that over to Stephen for you.
Yeah, so here's just a little bit of fun statistics about the hours that we put into this project. We averaged around 42 a week and hitting a total of 508. And here you can see some a little dip for spring break as well as some final preparations at the end. So that was really great. We put in a lot of time and effort into this project, and we're pretty happy with that. And a little bit about the team challenges that we faced together. So a big thing was scheduling. We all have part-time jobs on top of our semester work. So getting together and having group meetings is sometimes difficult. And that just means that our communication had to be that much better. We need to keep on top of each other, making sure people aren't completing other people's work or stepping on other people's toes, as well as everyone's keeping up to date on all their challenges.
Additionally, we had to make sure that we were dividing tasks equally among members of the team, that it played to all their strengths that they had, making sure that people got to do what they wanted to do on this project. But it's been a really great project. Enjoyed doing it. It's been a great team to work with.
Any questions? Don't be shy.
So they are using, as I said, SNMP credentials to scan through the network. I admit I do not know exactly how they get kind of the information and map it out, but they, like we uploaded it, and it like automatically just kind of found an initial mapping of the network. It like knew a device was there, but it didn't know what type of device it was. And then we gave it SNMP credentials, and it was able to find the rest of that information.
Yeah, sure. I'll expand on that a little bit. So yeah, it's SNMP credentials. You add it to certain networks, and it starts building out from there. And you're giving it the SNMP credentials, and then SSH allows for additional functionality, as well as with our firewall, we are actually using NetFlows, and we can get all that traffic as well in Auvik, which it's a really nice way of centralizing all that data in your network. Yes, you can also, the alerts on the right side, it's also collecting syslogs as well in Auvik. Any more questions?
Well, I think Nathan's the best qualified for that one.
Oh, yeah.
We'll touch on that a little bit later, just after this slide. Any other questions before we move on to that?
Yeah, it's entirely dependent on which sites your user has access to. So as long as that user has access to the site and the API credentials, then they would only see the site that they have access to. It would be the user that is on the back end making the query.
Anybody else? Are we ready to? Oh. Yeah, definitely. I mean, our code isn't quite hardwired. It's dynamic, so it'll be able to learn devices off the network, and it's fairly flexible.
So the devices that it pulls in there, we call it Cisco and ESXi just to make it easier for us because we only had Cisco and ESXi products, but it will pull any device that you have in there. So say we have a Meraki device or an Aruba device, as long as you've got the SNMP credentials in there and it can see that the device is in your network, it'll pull that in even though it says you're querying for Cisco. So you can put any brand as long as they do SNMP and you can have a console login.
Like how long it takes the bot to pull, or after the bot talks, it will query at every about 5 seconds for about a minute, and then it will go through the previous prompt and just say, hey, you didn't type anything back. So
The bot actually is only for retrieving, but in Auvik itself, you can actually SSH and connect into devices on that network. Perhaps that's something that could be implemented, but that also gives a lot more privilege and kind of security risk to those who have access to that kind of chat. Are we ready to find out about the bagel? Well, there's the bagel. We like bagels. Who knew? And now let's get ready for Arista.
For our second Capstone presentation, we will be switching gears to talking about next generation cloud networking, specifically optimizing a data center hosted in Google Cloud using technologies such as VXLAN and EVPN. So to start, let's introduce the team. I'm Brandon Ulm, and I took up the role of project manager.
I'm Brandon Behrens. I'm a network engineer and I specialize in EVPN.
My name's Cole Melson. I was a network engineer on the project and I specialized in configuration of the leafs.
I'm Lucas Rupp. I'm the security engineer and I focused on VXLAN and configuring the leafs.
I'm Javier Perez Sanchez, or Javi, and I'm an automation engineer who focused on network provisioning and configurates.
I'm Michael Long. I'm one of the cloud architects, and I focused on the spine configurations and cloud vision.
Now, before we dive into the project, we want to both acknowledge and thank our Capstone sponsor, Arista Networks, specifically William Goss, who is a systems engineer for them. Throughout this semester, William played a vital role in the team's success, from not only providing us with a bunch of content to help us become familiar with not only Arista hardware, but also some of the technologies used in this project. He also took time out of his busy schedule to meet with us on a weekly basis, as well as going above and beyond to provide any additional assistance as necessary, including even coming to UW-Stout a couple times to help us troubleshoot some of the issues we were having. So, on behalf of the Capstone team, thank you, William, for being such an awesome sponsor. Now, let's get into the project.
I'll start off by going over our project goals. Our program director and Capstone advisor have been going back and forth about potentially implementing a VXLAN and EVPN curriculum into the CNIT program. So as a group, we want to be the test bed for this potential program, seeing how well we react and understand these new technologies. That being said, we also want to learn and understand how to implement VXLAN and EVPN. Next, we want to grow the industry by using these non-proprietary solutions. This is the direction that the industry is heading towards, and we want to be at the forefront of that. And lastly, we want to gain experience by using next-generation network infrastructure, as these are tools we may need to use in the future.
Some of the business applications for these technologies we're going to be talking about is it's basically going to be for large data centers and campus environments. This technology is very complex and very hard to implement onto your network here, so it is not recommended for smaller companies or your own home networks. It's just a little bit too complex. But for the large data centers and campus environments where there's lots of traffic going through them, it's perfect. Some notable companies that already use these technologies are Netflix, AWS, Visa, and VMware.
So next I'm going to be talking about some of the things that we were tasked to do in this project. So first off, we were asked to create a layer 2 leaf and spine environment that uses MLAG, VXLAN, and EVPN in that environment. And right after this slide, I'll tell you exactly what our topology looks like. And then to host our topology within GCP, Google Cloud Platform, and then obviously as any network to ensure connectivity throughout it. So in our topology here, every device that you see is a layer 3 switch. However, if you take a look at the top row of devices, those are our spines, and while they are switches, they act more traditionally as a router would. The middle row of devices are our leafs, which act as traditional switch would, and then our hosts are just acting as hosts.
So for virtual hardware and software, we're using Arista's containerized EOS for our device's images. This is all inside of Container Labs, which is on Docker. All of that is running on a VM inside of Google Cloud, like Lucas mentioned earlier. We're using Cloud Vision to manage and monitor, and we're allowing that in through the Google Cloud Firewall. Next, we're going to get into the network configurations that we focused on and the technologies. First, we have multi-chassis link aggregation, or MLAG. MLAG provides redundancy, scalability, and load balancing in the network. Redundancy is achieved by an active-active state between MLAG peers. If one were to go down or one needs to be upgraded, the other one will take over all traffic. Scalability is achieved. Oh, I knew this one. Yep. Yep. I'll skip to load balancing. Load balancing is achieved by having both of them receive that across that end device link up to them. It is only seen as one device by the downstream host. Now in our topology, you can identify MLAG by the image on the screen now with 2 MLAG peers up top and the end device below. Some things to keep in mind for MLAG. MLAG is non-proprietary. Some vendors call it MCLAG or VLAG. And then lastly, MLAG is advanced for configuration, but once you understand what remains the same and what remains different between the peers, it gets much more easier.
Next, we're going to talk about some of the basic terminology that we're going to be talking about later in this presentation here, so we can all make sure we're on the same page here. So first, we're going to have VXLAN, which is Virtual Extensible LAN. Then we have VTEP, which is a VXLAN tunnel endpoint. A VNI is a VXLAN network identifier. We have EVPN, which is Ethernet Virtual Private Network, or EVPN. We have BUM traffic, which is going to be broadcast, unknown unicast, and multicast traffic. And then we have HER replication, which is head-end replication, and that is a route distribution method used by VXLAN.
So next I'm going to be talking about VXLAN. So VXLAN works very similar to the way a traditional VLAN would. It helps segment network, and it also works as an encapsulation method. So in VXLAN, you help set tunnel endpoints, or VTEPs, within your network. And these VTEPs help set relevant destinations within your network. And so by configuring flood lists can either be configured statically or dynamically. And in a data center environment, it's not very efficient to manually configure flood lists on every single device. So through the use of VXLAN and EVPN together, you can dynamically learn these flood lists and your relevant endpoints throughout your network. And VXLAN also helps with some scalability in a large environment, because a traditional VLAN network identifier is only 12 bits, which limits you to 4,094, where VXLAN is 24 bits and you can have up to 16 million.
So what is EVPN? EVPN is a technology used in computer networking to extend layer 2 Ethernet services over different networks. The key here is different networks. It's a standard-based protocol, meaning it is compatible with multiple different vendors, not just Cisco. To retouch on one of our goals, Arista wants to help grow the industry. To do so, they taught us technologies that every vendor can use. EVPN is learning and dynamically spreading route targets for VXLAN to work. What is it learning? It's learning MAC addresses, MAC and IP bindings, and IP prefix lists. One of its many advantages is the ability to support both layer 2 and layer 3 services across multiple networks. This means you don't need a data center. You don't need an external controller. EVPN is a control plane. Now, using BGP and EVPN together, this allows administrators to control and optimize the flow of traffic. To summarize, EVPN is a control plane with multiple data planes that can define layer 2 and layer 3 VPN services.
Now, to help explain exactly where EVPN and VXLAN lie in our network, I'm going to quickly explain the role of an underlay and overlay network in our data center environment. So to start with the underlay, its primary purpose is to provide IP reachability between our VTEP loopback addresses, which is a loopback address that exists on both all of our leafs as well as our border leafs. Now, you can use any major routing protocol you'd like to act as your underlay control plane, but by far the most common and often considered best practice is to use BGP, with our peerings being on all of the point-to-point links that exist between our spine and leaf devices. This lays the foundation for our overlay network, with its purpose being to provide services to tenants, such as our layer 2 and layer 3 VPN, via VXLAN. This is done by now leveraging EVPN as our overlay control plane through the use of the EVPN address family that exists inside the BGP protocol, with our peerings now occurring on all those loopback addresses that previously became reachable because of our underlay network. Now, once EVPN is established, its dynamically advertised information is what will allow VXLAN, operating as our overlay data plane, to do the actual encapsulation and transportation of those packets in our network. So both of these concepts will be further showcased in our live demonstration, but for now, I'll hand it back off to Brandon.
Thanks, Brandon. Why do we use EVPN and VXLAN together? They need each other to work, and here's how. VXLAN enables the creation of virtual layer 2 networks over a layer 3 infrastructure, while EVPN is able to advertise the information and the location to those connected endpoints. EVPN flags packets with a VNID, while EVPN is able to use those headers and associate a MAC and IP address to specific VXLAN segments. VXLAN uses head-end replication of BUM traffic. This means traffic is only sent to relevant destinations. And finally, EVPN provides isolation, meaning multiple tenants can remain on the same physical infrastructure while maintaining a logistical separation. In the next slide, this is what our physical topology looks like. Once our technology is done with it, MLAG will turn those two leafs into an MLAG pair. And VXLAN and EVPN will turn those routers into one point. From an endpoint perspective, host A sees that MLAG pair as one device, and likewise for those routers. Doesn't matter if you have 100 routers underneath that cloud, it's not going to change much.
So now you may be asking yourself, what are some of the real world applications and benefits of these technologies? So with using VXLAN EVPN, you can make your network very scalable, as learning those relevant endpoints are dynamically learned. And with your devices, these leafs, so much of the configuration is the exact same between the same devices, because they're acting as one device. It can make adding devices to your network fairly simple. And because our network is a full topology network, there's plenty of redundancy in case one device goes down, or in an MLAG peer, if one device goes down there, the other one will simply pick up the slack. And then one of the main reasons why we use these technologies together is to reduce network congestion. So by using both of these together, traffic will only target relevant destinations, and then later in our demo, we'll show you exactly how that works.
So by using EVPN and VXLAN to move communication from layer 3 to layer 2, we're solving for poor application design. An example of this would be VMware's vMotion technology, which allows a system admin to migrate a server across layer 3 links using layer 2. By doing this, we can send a server across different data centers or just much further. Now we're getting to our EVPN and VXLAN demo.
In our first demo, we will be showing you how the underlay works, which is not participating in VXLAN. My friend Cole here is going to show you where host A and host C lie on our network. He's going to take host A and ping to host C on VLAN 400 to VLAN 402. We should see a successful ping. Now we will do a trace route between those two addresses, and a trace route will show the hops, or the amount of things in between it and its destination. We are expecting 4 hops. Survey says 4 hops, just as we expected. Back to our slide. In our slide, we will be showing you how this packet goes from host A to host C. Host A will issue that ping, escaping its gateway, going to leaf 2 on BGP. It'll go to spine 1, border leaf 1, and then back to host C. Again, this is how the underlay network works. Passing it off to Brandon.
Thanks, Brandon. So for the second half of our network demonstration, we are now going to be showcasing our overlay network. So to do so, Cole is going to go back into host A, and we're going to issue another ping and another trace route to host C, this time through VLAN 100, which is participating in VXLAN. So as you can see, the ping is still successful as we have connectivity through that VLAN. And now, based off the demonstration we just showed you, we should expect to see the same number of hops, right? We're going from the same host A to the same destination. But as you can now see, host A only sees 1 hop to host C. Why is that happening? Well, we'll go back into our presentation to help better explain what is going on behind the scenes. So here is a diagram representing our overlay network. Some important things to note is that our control plane is now EVPN instead of BGP, and our data plane is now VXLAN. The color-coordinated VNIs in our overlay are used to showcase what VLANs are mapped and participating in VXLAN on all of our VTEP leaf devices. So for example, leaf 1 and leaf 2 have VLAN 100 and 300 mapped to VNI 1010 and 1030 respectively. And you can follow that naming convention for the rest of our leaf devices, noting that the border leafs have all 3 VLANs participating in VXLAN. So now we're going to show you how all the technologies we've been talking about today are working together to make this 1-hop trace route possible. So host A is first going to initiate that trace route to host C and broadcast that out to its gateway, this still being in our underlay network. From there, the traffic is then going to reach one of its 2 connected leaf switches. Because of MLAG, host A sees them as the same upstream device. That receiving switch, if it does not know any information about host C, would simply broadcast that bump traffic out of all of its interfaces, including its VXLAN interface. Now, since VLAN 100 is locally mapped to VNI 1010, it's able to use its VXLAN table, which is advertised by EVPN, to find the VTEP addresses of the 2 devices that are connected to host C, this being either border leaf 1 or border leaf 2. From there, VXLAN is going to encapsulate that packet with that 24-bit VNID, and using her replication, VXLAN will then flood the packet only to relevant destinations, this being either border leaf 1 or border leaf 2. From there, the receiving border leaf, since it also has VNI 1010 locally mapped to VLAN 100, is able to de-encapsulate that packet and remove that header, which at this point translates it back into our underlay network. From there, the border leaf is simply going to forward our traffic to host C. So, because of the way that of the information that's advertised through EVPN, and because the peerings for EVPN are on all those VTEP leaf devices, VXLAN is then able to take our layer 2 traffic and extend it over our layer 3 by simply forwarding traffic directly from one VTEP to another, which is why, from host A's perspective, it only sees one hop to host C, showcasing what both EVPN and VXLAN together can accomplish in your network. This concludes the network demonstration portion, and we'll hand it over to the CloudVision team.
All right, so next we're going to talk about CloudVision, which is kind of our one-stop shop for networking. We're able to easily onboard and manage and monitor all of our devices on our network from one simple location on the internet. And we can then see real-time changes to all the configurations on all of our devices up to the exact second that we want to see, and we can go back to from the second that we onboarded that device, so we can see the current configurations and the previous configurations as well. A good example of this is, let's say a device in our network goes down. We don't know what happened to it. We can go back and see what changes were made on that device, and we can roll it back to a previous working state to get that device back up and running. We're also able to create and push configlets onto our devices. Configlets are little blurbs of configuration that might be known as tedious. So we're able to create those with Python and push those configurations out to either one device or multiple devices on our network, making those somewhat tedious tasks a little bit easier and faster and more efficient. We're going to be showing you a quick demonstration on that, so I'm going to hand this off to Javi.
As Michael's going to be pulling up the CloudVision, I'll be showcasing what creating and pushing creating configlets looks like. So as you can see here, this is a hierarchical tree view design of our network. Inside of containers, which are logical entities, are our devices. You can push configlets into containers or devices as you'd like. To see what a configlet might look like, Michael's going to go into the configlets tab, and then this is an example of a Python script. So what this script is doing, it's grabbing a host name, and then if it matches that, if the device is matching the host name on the configlet, it is then going to create a bunch of loopback interfaces. In this case, it's creating 25, and then it's going to add a bunch of IP addresses to those loopbacks to see what this is going to look like. You can choose a device and then generate the configlet, which will give you the built design. As you can see here, that's what it's going to look like. So then to create and push, or to push these configlets, you can go back into network provisioning, and then right-click on a device or container, and then managing create configlets. From there, you can select the configlet that you want to add, and then you can generate the configlet for that specific device. And if you want to see what the configlet is going to look like again, you can expand on that configlet. And then from there, you can just you can validate the configlet inside of the device. From here, you'll have running and design configuration. Inside the running configuration is what's going to be added to the device. In highlighted in green, you'll see that there's a bunch of loopbacks with their IP addresses. So all you have to do is save the device, and then you have to save the changes inside of CloudVision. From here, what it's going to do, it's going to create a pending task. To confirm and approve that task, you can go back, or you can go into the task bar, and then from there, you can select the pending task that was just not created, and then confirm that this is what you want to do. From here, you can review and execute the task. It'll bring you another page highlighting green of all the changes that are going to be applied to the device, so you can execute immediately. And while this is loading, one benefit of using configlets, so say you wanted to apply that many loopbacks to a container which had 3 devices inside of it, that would be quite the bothersome task. So you can use a Python script to dynamically create all of these configurations instead of having to SSH into those devices and create them yourselves. So as this finishes, which is taking a little bit, Michael will go back into the graphite topology view. There it is, 100%. All right, so now if he goes into that device that we just applied the configs to, you will now see all of those loopbacks and IP addresses that were dynamically created inside of that device. I will now be passing it over to Michael, who will be going over more about CloudVision.
All right, so we're going to also talk about some of the more basic features of CloudVision as well to kind of give you guys a better representation of what we're working with here. So we're going to quickly go into our devices. This is the inventory of all the devices in our network. We can clearly see they're all active and live streaming into CloudVision as we speak. We're going to quickly hop into the Borderleaf 1 device, which we just made some changes to, adding those loopbacks. We can see that it's currently streaming in, it's currently ready, and it's good to go. So we're going to hop in there. We're going to make another configuration change on there. We're going to show you guys how quick it actually does stream into the CloudVision platform here. So we're going to do a quick host name change. We're just going to make it a lowercase so it doesn't mess with our network too much. And we're going to see exactly how fast it streams. And it's already in CloudVision there. It already has switched the host name, as we can see right there. Now we're going to go show you guys how we can compare the two configurations from before. So we're going to go to a time comparison. And we're going to select the Borderleaf 1 device that we just changed the host name on. We're going to go see the configuration from now and 30 minutes ago. So let's click compare, hop over to configurations. And the configuration on the right is the current configuration that the device is running at this exact second. The one on the left is the one that was exactly 30 minutes ago on the same device. As we can see, it's a little hard to see on the screen, but there is a red outline. Everything red is different, so we can clearly see what has changed on the device. So again, like I was saying earlier, if something goes wrong, we can see exactly what was changed instead of having to look through the exact every single line. It kind of outlines it for us there. And that kind of concludes our CloudVision demo. We're going to move on here.
So next I'm going to be talking about some of the challenges that we faced as a team. So at the beginning of our project, some of the issues we had were installing Docker. So in order to use Container Labs, which hosts our topology, we had to install Docker. And for some reason, we were all following the same steps, but Cole's worked and ours didn't, which is frustrating. But eventually troubleshooted that and sorted that out. And then we had some issues with enrolling devices into CloudVision. We had a name server issue, troubleshoot that, figured that out. And then with Google Cloud, every Gmail account is given $300 of free budget to use. And in order to meet some budget constraints, we had to use a spot instance, which unfortunately Google can shut down our instance if they need to reclaim resources. So that means we'd have to turn it back on and then onboard all of our devices, which was a bit of inconvenience at times, but it is what it is.
These memes represent exactly how we felt at the beginning of the semester. We spent approximately 3 weeks doing training, watching slides, and doing labs on EVPN and VXLAN, but they are very difficult technologies. It took us maybe 3 months to finally grasp and understand what is happening.
And finally, to wrap up, in the little over 600 hours that our Capstone team spent working on this project throughout the semester, there's obviously some key takeaways and lessons learned along the way. One of those being the need to continuously improve our communication skills, especially in a bit of a larger team where our devices were split up amongst its members. Even a small network configuration change on one device, such as we learned with a different UDP port, can play a big role in the whole success of the network. So the team worked not only on improving our verbal communication skills, but also making sure to document all of our changes so that we could reference it later on if need be.
As a CNIT program here at Stout, all we know is Cisco, so we've been quite accumulated to using Cisco CLI. So getting our hands on with Arista CLI was a really great change of pace, as there is more to life than just Cisco. And finally, as I mentioned earlier, these are new technologies and new protocols that we're using. So even though we may never use these again, these are just tools inside of our toolbox. This concludes our presentation, and we will now open the floor to questions.
Yes. I am not sure off the top of my head, unfortunately.
or something like that, what I've seen in the dampening mechanism for the updates, it'll limit how many updates it can receive for a particular endpoint being a virtual network. If those periods for Arista is doing something different. So for any of your but when it sends out a new type 2 or 4, advertise for VPN, there's a flag that's set at the time.
It's a great example of this technology is still very complex, and even as a team working on it throughout the whole semester, we still have barely even probably scratched the surface in some of the really in-depth stuff that it goes into. So,
Yep.
I think it would be personally a really good upper level class. Like, it is challenging, and that as upper level CNIT students, we want to be thrown everything but the kitchen sink, right? To help us moving into our professional careers. So I think it would be a great class. Like, again, it is hard, but they're really cool technologies, and in the up and coming world of networking, like, these are going to be at the forefront of it and are becoming more and more popular in recent years. So to have that knowledge, again, even if we don't use it, to have it is just another tool that we can potentially use later on in life. So I think it'd be a great class. Any other questions? Seeing none, thank you all for listening to our presentation, and we're going to now hand it over to Network to Code.
Alrighty, we're going to take a quick 5-minute break here. Feel free to use the restroom, get a drink of water, and then we'll get started with the Network to Code and Arista presentation after that. Alrighty, we're going to get started with our third presentation of the day. For our team, we ended up designing a unified Nautobot CI and CD automation framework for Arista networking devices. So for our team, my name is Colin Palakos. I am our project manager and framework engineer.
I am Dominic Cavallari. I'm our platform engineer.
I am Drew Bonney. I'm the CI/CD engineer.
My name is Nicholas Constantine. I'm the network engineer.
I'm Ben Janicki. I'm the database administrator.
So a little bit about our sponsors for the project. First, we had Network to Code, where we had our wonderful Josh helping us out. Network to Code provides services and softwares for around network automation, specifically for this project using Nautobot as our source of truth at the very center. And then we also had Arista Networks, where we had Will be very helpful. Arista provides cutting-edge network devices with enhanced industry standards CLI, which is really great for learning network engineers. So a little bit about what we're going to be talking about today. We're going to start off with our problem statement, go into a bit of an overview and the overall design of our framework before we head into the live demonstrations. Then we'll wrap it up with some lessons and growth.
So what exactly are we trying to solve with our solution? Well, overall, when you get to an enterprise level, managing and maintaining the configurations of a bunch of different networking devices can get really complicated, especially if you're saving them all in, one folder on your desktop, something like that. Manual configurations as well as code checking can also take an incredibly long time, and it's really prone to human error. Can make a lot of mistakes. I know I do. And, also maintaining that compliance, making sure that visibility throughout your network, making sure all your devices are as they should be, is just a really big challenge and can take up a lot of time. So what we've kind of developed for our solution, we have at the start, at the source of our whole network, we have Nautobot, which is our source of truth. It maintains a lot of our device information and can be used by a bunch of our other services in order to query and get information that is essential for them to run. We also have our telemetry and monitoring solution, right? We have a combination of OC Prometheus, which is an export developed by Arista, Prometheus, which is a time-sensitive database, as well as Grafana, graphing software. All those three will work together in order to present to us the statistics going on in our network. Then we also have for our CI/CD pipeline, we have this wonderful technology called Jenkins to really automate a lot of our code validation. And obviously for our remote code deployment, instead of manually logging into all of our devices, we like to use Ansible in order to deploy all of our code. And now I want to do Colin to talk about our source of truth.
Yeah, so Nautobot as a source of truth. What is a source of truth? So you can kind of think of it essentially as a phone book for all of our network devices. So everything is stored within there, as well as information about like interfaces and configurations. And then all of our other tools within the framework are going to be reaching out to Nautobot to get the necessary IP addresses and login credentials so that they can perform their tasks. So for Prometheus, in order to figure out what its targets are and find all of the devices on our network, it reaches out to Nautobot to get that list of devices and the targets that then can graph into Grafana. So I'm going to hand it over to Drew now to talk a bit about our pipelines.
Okay, yeah, so another important aspect of our automation framework is, of course, our CI/CD pipeline. We built this using a tool called Jenkins, and basically what it does is it allows us to speed up the code development for a company by using different tools that can automate certain aspects of software development. So for example, we use PyLint and AnsibleLint to verify for the correctness of code. So are there any unintentional mistakes or errors within the code that were missed while it was being developed? We use Rough to automatically format code into the style that we want so that developers don't have to manually do this. Then we have Python Bandit, which is used to scan code for any security issues that may open up a business to some form of attack. And when you use all these together, you can really see how it can save a business a lot of time and headaches at basically the click of a button.
So the main tool that we are using to automate our deployment of network configurations is Ansible. And Ansible is an open source IT automation engine that automates common IT functions with major support from big technology vendors such as Cisco and Arista. And everything was readily available through the default Ansible app repository. And so what Ansible needs to deploy changes is an inventory, which is basically a list of all the devices that you own in your in your business. So that's what Dominic's hit on perfectly before. Obviously, it's very, you might have hundreds of devices, and with the movement towards infrastructure as code, you could have even more devices that you need to manage, and it's not very manageable for a static inventory file, which is what Ansible defaults to. So as part of our pipeline, we integrated Nautobot as a source of truth. So we were able to make something called a dynamic inventory, so that Nautobot can provide all the necessary information that Ansible needs to deploy configuration changes to our devices. So we remove that need to have a static inventory that we have on our machines that run Ansible. So I'm gonna lead off to Ben now to talk about our project goals.
Thank you. So in order for this project to be accomplished, we need to meet the requirements of 3 goals, all of which are all about making the life of network administrators easier and saving money. Our first goal here is to streamline the process of configuring our networking devices by using automation. So configuring network devices takes a lot of time. It's prone to error, especially if you're doing everything manually. So what we want to do is implement solutions to automate this, make it less prone to error, speed it up. Our second goal is to use open source solutions. Now, the benefit of using open source solutions is that they're completely free, and we also get to participate in the open source community. So we can get insight from people in the community, and we can also contribute to it with new knowledge. The other benefit of open source solutions is that they're highly customizable. And our third goal here is to streamline the process of maintaining our network. So once all the configurations are in place, maintaining it is a whole nother story. We're going to need to identify exactly when and where things go wrong, be able to see exactly what's going wrong, and quickly fix the issue.
Yeah, so just to go over some of the business impact, we've already kind of briefly touched upon some of this stuff. What we really want to drive is decrease in complexity and time consumption through like manpower hours, and really increase the visibility we have on our network, increase the scalability of when we add 20 more devices, how easily can we add those 20 devices, how much time it's going to take, reduce operating costs. I mean, this project was so cheap that the most expensive thing I had to buy was the suit I'm wearing. It was got it on Amazon, so pretty great. And as well as make this solution really vendor agnostic. And so it's not just a Cisco focused technology. These are open source technologies that you can use in any network. And so really the business impact is just how easily accessible these tools were for us. So going to Colin.
Yep. So I'm going to talk a little bit about our topology before we jump into the live demo. So one of the really nice things is everything is entirely within GCP, Google Cloud Platform. So if you're interested in seeing if this is the right fit for your business, GCP does offer a $300 credit for your first 90 days. So you can really get to test out if this framework would be the right fit for your enterprise. So we currently have a total of 5 different virtual machines that are running. Nautobot, which is our source of truth. Ansible is just a desktop client where we get to deploy our Ansible playbooks. We have Jenkins, which is running our pipeline for our CI/CD, and then our telemetry virtual machine. And the center of everything is Container Labs here. So Container Labs is what allows us to virtualize all of our switches and routing information. So we don't necessarily need to invest in that hardware to figure out if this is the right solution for us. You get to do a lot of experimenting and exploring within Container Labs. So, and a big shout out thanks to Arista for providing us their EOS so that we could, for our purposes, we only created a small network of just 3 devices, but you can scale Container Lab up to hold up to hundreds of devices to really see if that's the right fit for your enterprise. So we're going to be jumping into our live demo here now. So it is going to cover a lot of different kind of more the DevOps side of things, because that is more what our framework is geared towards. So we're going to be starting off taking a look at our Google Cloud Platform. Exit. All right, so this is what GCP is going to be looking like. So we have all of our virtual machines hosted here, really nice. Does provide internal and external networking, and we can establish SSH's sessions into any of our devices at any time. So we're going to go ahead and SSH into our Container Lab, kind of show you what the back end of our network looks like. logged us back out. So one of the things within the container lab is we have a very important file that is what connects us to Arista software in order to configure all of our devices. Also within there is a graphite module. So we have our graphite node right there, which creates a very nice visual topology. It shows all the device names, as well as allows you to SSH into the devices individually. Then you can set all of the different switches you want, set IP addresses, set what ports you need open. You can do other devices besides just switches as well. We have a host in there, just a Linux PC. And then you can also just add as many connections as you want. So if you have a switch that's in the center of your data center, you can add the dozens of connections. Or if you just have a one-off sitting in a closet that you want to simulate, you can do that as well. So when we actually go into that graphite module within Container Labs, as I said, it nicely visualizes it. You can SSH. As I mentioned, Arista does have a really nice enhanced industry standard CLI, very easy to use. And you can also run a simple bash command and get into the Linux shell that is underneath that switch. So if you're needing to troubleshoot with Linux, that's also available for you. So I'm going to be handing it over to Dominic now, who's going to be talking about Nautobot, our source of truth.
Thank you, Colin. Appreciate it. So we've been talking a lot about Nautobot, so really want to get you guys more of a visual of it. So right here we have all of our beautiful Arista switches onboarded into Nautobot in order so that it can contain all that device information. We can go into these switches anytime, look at the interfaces they have, starting and running configurations, and a bunch of other details, and it can be really, really expansive if you want, or if you don't need all that information, you don't need it as well. So one of the wonderful things as well about Nautobot is its jobs. Now these Nautobot jobs that we're going to be using in particular are backing up our configurations as well as generating configurations. Now what would usually take any network engineer to manually go into a switch and back up the files even to a TFTP server or on a flash drive could take a while, again, especially if you have a bunch of devices. However, with Nautobot jobs, with one click of a button, which is basically our catchphrase for this, you can do all the backing up. And also with a few Jinja templates and a GitHub repository to store all the information, you can generate these configurations as well really, really quickly just based on a couple of context, you know, like what's the device type, what's the location. So really, really simple. Here's a GitHub repository as an example. Now you can go into the normal switch config or the backup config. Doesn't necessarily matter for this example, but it's just like that. It's that simple. It's that quick. Now, it also, one of the wonderful things about GitHub is the fact that it does the commit tracking. And with that, you can see the history of the configurations where things are changing. So if anything goes wrong, you can see where it went. Another wonderful thing about Nautobot is its compliance plugin or goal configuration. It has a compliance feature. So if we run our compliance job really quick, you know, it's going to run and it's going to say, hey, since the last backup, is anything different than the compliance rules that you set? And we're going to go back to the compliance report. Hey, one of our jobs or one of our devices is non-compliant, right? It violates one of the rules that we've set. And so this, you know, really expands on that visibility that we're talking about and knowing exactly when and where devices are going wrong as soon as we can. So to talk a little bit more about those Nautobot jobs from earlier, we have Drew to talk about our pipeline.
Yep, so again, another big part of our automation framework is our pipeline. And basically what it does is it allows a business to speed up and automate their software development using different tools that can automatically scan code or format it. So up here, we do have our pipeline that we built in Jenkins. So again, we have a formatting step that will automatically format code to how we want it, rather than a developer manually having to go through. We have our linting step, which is where it verifies the correctness of code. It makes sure there's no unintentional mistakes or errors. And we have our security scanner step, which will scan code for any security issues that could open up a business to an attack. So to kind of show a use case of this, I'm going to kind of take on the role of the software developer. So within Nautobot, jobs were talked about by Dominic just a little bit ago, but these jobs are made entirely using Python code, and they can perform pretty much any automation task you can think of. So for example, I actually developed a job that will pull CVEs from the internet, and CVEs are basically software vulnerabilities that a company should know about, and it puts them into Nautobot. And so it's actually a very possible use case that a business might have. So again, I'm taking on the role of a software developer. I'm making the code for that job, making changes. I save my changes. And then in the background, my code is running through that pipeline. It's getting reformatted. It's getting scanned for any security issues or errors. And then it will spit out a report into GitHub that the developer can then look at. So it shows that my file was changed. All of these are issues or errors within the code that were found that I should look into and fix. And it even detected a security vulnerability. So if we actually follow the link for that vulnerability, it basically tells me that within my code, I have something that opens up my business to an attack that could either slow down parts of the network or completely shut them down. So you can see how all these things working together can really save a developer and a business a lot of time, money, headaches with basically just a click of a button. So yeah, and then now Colin is going to talk about a different pipeline that we made for Ansible code.
Yeah, so an important part of network automation for us is using Ansible to manage all of our devices and apply configuration changes in mass versus having to go into the CLI of each device and make changes. So important thing as within DevOps is when you're making playbooks for Ansible, you also want to make sure that there's no errors within that code, because in the event that it won't run the playbook properly, it could cause problems with your network devices and possibly cause network outages if that right configuration doesn't end up getting pushed to your devices. So within our GitHub repository here, we kind of have a version history of all of our playbooks that we're currently using. I also just want to show you a little bit of the kind of the guts of what a Jenkins pipeline looks like. So you can set different stages within here. We can kind of flip-flop between one of our older playbooks and one of our newer playbooks to run through the pipeline to see those different errors. So when we head over to Jenkins, we're going to get this big, scary red X, but that's actually a good thing, because this is one of our older playbooks, and with Ansible lint, it tells you exactly what line that there's errors in your code and what that error is and how to resolve it. And then once you make those changes and you run it again on one of our newer ones, you'll see you get that wonderful green check mark, and our Ansible lint tool has told us that is running at a production level. So we're really good. We're in the green to go ahead and apply this to our network. The playbook is not going to error out, and it's going to prevent any network outages. So I'm now going to hand it over to Nick and Ben, who are going to talk more about Ansible.
So as we've discussed before, for Ansible to deploy configuration changes to our devices, we need an inventory, which is a list of devices that we own. And then as you can see up there, this is a classic example of what a typical Ansible inventory looks like. So at that top section, we have our connection variables, which is what Ansible uses when we connect to a device to log into it and to deploy changes. And then on the bottom, we have our 3 switches linked into a group. So two big problems with this inventory is that it's a static file. So if it's like as we said, we deploy everything in Nautobot. So if we add a new device, that's where you want to onboard it onto. That way, that inventory can update for us. But with the static inventory, whenever we make a change to the network, this data will become out of date, and we would need to run a playbook. We would need to run a playbook to repopulate the information with up-to-date information. That, or we could edit the information ourselves. So this isn't a very scalable solution. So I'm going to kick it off to Ben now, and he's going to demonstrate how we were able to use Nautobot as our source of truth to basically compress this inventory down into just a 4-line configuration file for our dynamic inventory.
Thank you, Nick. So here's our updated inventory file, which is a dynamic inventory. It only requires 4 lines of code. And essentially what's going on here is all of the devices that we've onboarded into our Nautobot server can be directly accessed with Ansible from this inventory using a GraphQL query. So as Colin has shown the inventory being listed, you can see all of the devices and all of the connection information that you would need to SSH in and apply changes via an Ansible playbook is already there. So you don't actually have to go into an inventory file and manually update connection information. And the benefit of this is that it makes your network extremely scalable. So you can add devices, you can remove devices. You don't have to worry about your inventory file because it's dynamic. Ansible's always going to know which devices are on your network. So one of the things we can do, for example, now is run a playbook. And one of the ones we did, it configures the prerequisites on our switches necessary for our telemetry solution to work, which Dominic's going to talk about now.
Yeah, so just a really quick brief overview on kind of what we did for our telemetry system. Once again, we had an exporter running on the switches, and this exporter is reached out to from Prometheus. It is getting the information. Right now, we have it tracking our BGP peer states, our link up states, and also some of our CPU information for our devices. Now, you notice that one of our 3 switches is not up here. That is because it was not compliant with the configuration, which we noticed earlier. And so once again, kind of wrapping that around, having that knowledge and that visibility, which is really what all this monitoring, configuration, telemetry stuff is about, knowing what's going on with your devices, seeing if there are any outliers, just super important to our network overall. So this is kind of wrapped up a lot of what our demo has been. So now we're going to get into some of the, Nick is going to start talking about some of our lessons learned.
So one of the lessons that we learned as part of the Ansible team is that inventory files should only contain essential connection information. So this was we got help in particular from Will. He provided us feedback with our first prototype of our inventory, and it wasn't exactly what he was looking for as part of our statement of work. So one of the lessons that we learned is the value of collaboration and continuous development of code, because as we've seen with other previous speakers, code is everything now with automation and DevOps frameworks. So it was definitely a lesson that we all learned.
Mm-hmm. Another wonderful lesson that we ended up learning, contributing and reaching out to the open source community. I, at one point, had been a bit puzzled on how to actually make Prometheus reach out to Nautobot as our source of truth, but quick query into 1 or 2 platforms, very quick responses back, some collaboration, some ideas bouncing back and forth helped me develop a custom script that allowed Prometheus to reach out to Nautobot to use those as its targets that it found. So actually using the open source community was an incredible lesson that we ended up using because we haven't really done something of that caliber before, and it's really interesting.
Yep. Another lesson that we learned was that in order to use network automation, code is basically a necessity. Basically, every tool that you saw today used some form of code in order to perform its function or to configure it a certain way. And that's just something that we did not really know network automation was all about before this project.
Yeah. Also, Container Labs was very useful for us as continuing learning as network engineers, being able to simply run a destroy and then startup command to completely restart that environment. So we really got to get some hands-on experience. Arista had provided us with several labs that we really got to learn how their hardware would work. Also, they provided us with some great automation seminars that we were able to attend to learn even more about network automation. So then going into some of the growths and challenges that we had, one of the big areas we grew in was our ability to work as a team in our administrative work. With building a framework, this is just some of the small applications that you might end up using this kind of framework for. Really, every part of it is reliant on another, with Nautobot being at the core of everything. So being able to work as a team and also having really good, strong documentation to be able to share with each other so that we all knew how every aspect of the framework would operate.
General, another growth, tying it back to the open source stuff once again. We are very primarily Cisco focused at Stout, has been mentioned before. And while we do touch upon a couple open source technologies, it hasn't really been the main focus of any of our classes or experiences. And so for our entire project to be founded in open source and vendor agnostic technologies, honestly, was really interesting. We got to research and get a much greater knowledge of, hey, basically everything out there has an open source solution, and it might just be the right fit for your network. And it was really fun to actually, once again, get into that kind of community and learn a lot more about that technology.
Yep, and again, this project had a huge focus on code. All of us had to learn different languages like Python, YAML, JSON, how to use GraphQL, how to write Ansible playbooks. All that requires, some type of code. And So it required hours of delving into different code bases to learn about them and figure out how to use them. And considering everyone here is a networking major except for me, so it really shows that how our team is able to grow and learn new things because they have not worked much with code. So, and that's it for the presentation. Thank you all for listening. Now we have time for questions if you have any.
Yeah, so the question, I'm just repeating it for the live stream, was did we have to find all of our tools or they provide for us? Some of the things like Nautobot, that was a give from Network to Code that we needed to use that. But as for like the pipeline and what telemetry solution we would use, we got to do the business practice of making architecture decision records of what's better. So like for our pipeline, we were considering using the push actions within GitHub or Jenkins, and Jenkins ended up working a lot better for us as it offers a lot more programmability. Dominic did a lot of research in the different telemetry solutions and which one would work best. We went through, what, 2 or 3 different ones until we stuck? Yeah.
There's a little bit for each part of it, the exporter, the actual database used, and then what you use to graph the information. So.
Yeah, so it was great to kind of really research different tools that we could use to kind of achieve the same thing, but what really works best for our solution. Any other questions?
You guys mentioned being vendor agnostic a couple of times. The solution you ended up coming up with, would it be vendor agnostic for the type of network equipment it's connecting to?
Yeah, so the question was about how agnostic it was, especially with network equipment. Yeah, you could set this up with Cisco, you could set up with Aruba, HP, really anything. For Container Labs itself, it kind of depends on if you can get that virtual EOS, but if you want to just set up your own network with real hardware, you can easily connect in our solution into that as well. So, and Nautobot and everything is all, will work with Cisco devices instead as well. So.
So what would you say is the most challenging open source tool
What was the most challenging open source tool?
I would say it's a bit of a difficult question because we each kind of primarily had our focus on our individual tools. So I think we could each say, mine was the most difficult. No, mine was the most difficult. We have a little back and forth argument about that. So I would say it's kind of hard to say. I know for me personally, a lot of the telemetry stuff, especially working with like GNMI, was something that we hadn't really considered or been learned about before. And so that for me was some of the hard stuff, learning about the different config paths and how the different, again, it's like 3 different things working here. So that for me was the most difficult, but that's also what I focused on. I'm sure Colin and Drew could talk about the pipeline. I'm sure, you know, Nick and Ben could talk about Ansible. So it, you know, kind of a really toss up, but we each had our fun with, we each had our own demons and our own fun with each of what we worked on. Anyone else? All right, well, thank you guys very much. Really appreciate you listening to our presentation, asking the excellent questions. Next up, I believe, is Heartland. Heartland Business Systems, everybody, for their presentation.
Good afternoon, everybody, and welcome to the fourth of the 5 Capstone presentations we have for you this afternoon. We are the Heartland Business Systems Capstone, and our project was Cisco ICE, transforming SMBs with next-gen network infrastructure and security solutions. Real quick, let's introduce our team. We'll start on this end and work our way down.
I'm Jacob Zonlak. I was one of the network engineers.
My name is Caleb Sinner, and I was one of the systems engineers.
My name is Carson Bogner. I was one of the cybersecurity engineers.
My name is Brennan Kukowski. I was the project leader. That is why I have a green tie.
My name is Marcus. I'm a network engineer.
And my name's Ben Freilich, and I'm the systems engineer.
All right, so a little bit about Heartland. They are a managed service provider. They've specialized in small and medium businesses and enterprise level IT solutions. Their main headquarters that you can see in here is Little Chute, Wisconsin. But of course, they're all over Wisconsin and part of the Midwest as well. I'd also like to take this time with me and behalf of the group as well to thank Heartland for also supplying us with the necessary network equipment that we need for our project, as well as assisting us through our struggles that we had overcome through Heartland as well. So for our problem statement, basically this company named Black Dog Manufacturing has suffered a recent security breach due to a misconfigured port, which causes the network to be down for a lengthy amount of time. But once they finally got back up, they contacted us, Heartland Business Systems, for a more up-to-date network solution and proof of concept with Cisco ICE. For those who don't know about Cisco ICE, it is an identity management solution. It has plenty of other features like downloadable ACLs, dynamic authorization, network administration control, and so on. Also, with additional services as well with Black Dog Manufacturing, once in their proof of concept, is Active Directory, DHCP, DNS, PKI, group policy, and multi-factor authentication with Duo.
All right, now let's talk about some of our deliverables. We have multiple services woven in to not emphasize security, but recoverability and fault tolerance as well. But how exactly did we do this? Well, to start, we have Cisco ICE as our main identity management solution, and we also are pulling VLANs and ACL information from Active Directory. There's also a change in authorization within our flow policies from ICE within Radius itself, and well, with non-802.1x devices, we have method authentication bypass and identity PSKs. And this basically sets the groundwork for bring your own device policies and guest policies with something called a walled garden. What does that mean? Well, a walled garden is basically a barrier that separates devices on the network. They need to authenticate the user and their device first before they can actually access the network, as well as being able to have some restricted control over it. Finally, we have our Veeam as our data backup solution, and we have multi-factor authentication via Duo. Now we're going to take all of these services, and we are going to make sure that they scale not just into our network, but we also have them safely accessed via ICE, and that this applies to all of our services as well. Also, we want to conform to not just Cisco and VMware best practices, but to Heartland's business practices as well, and to ensure that we can accomplish this for the business we designed this for, Black Dog Manufacturing. Thank you very much. I'm going to pass this off to JC now.
So this is our lab setup we had for our new network. We are using 2 Cisco 3802 access points. We are using 4 layer 3 3850 switches along with 2 4500X core switches. We are also using 2 Cisco Fiber Interconnect switches as well as 40 terabytes of nimble storage for our storage area network. We are also using a Cisco UCS chassis that has 5 compute blades along with a Cisco 9800 wireless controller. So this is our topology right here, and there's 2 things I want to point out. The first part is our IDF switch stack. So IDF stands for Intermediary Distribution Frame. It simulates network closets in separate locations. The second part is our core switches. So our core switches are running in an VSS configuration. VSS stands for Virtual Switching System. It's a Cisco proprietary protocol that joins multiple switches together into a single control plane. It avoids the need of a first hop redundancy protocol like HSRP or VRRP. VSS stores configs into each switch individually, so if one switch were to go down in our network, the second switch can take over immediately as the independent switch.
All right, I'll be talking about Duo Desktop MFA. So what is Duo? Duo is a proxy that reaches out to the internet, and there is a client on all of our Windows servers that also reaches out to the internet to connect to the Duo dashboard. And how that works is that there is an integration key, a secret key, and an API hostname that you enter into the client as you install it on Windows so that it's able to communicate with our Duo dashboard. And this little demo here is me going through our Veeam server, logging in there. It'll send out a notification to my phone. I click accept, and it'll log me into the server as usual.
All right, next I'm going to be talking about basically what runs our entire network here, which is Radius, and specifically a Radius attribute called change of authorization. Now, I'm sure most of us here are familiar with Radius. It is one of the essential protocols that tools like Cisco ICE use to get telemetry information about our network and make certain changes and authenticate us when we want to make changes instead of just a simple local username and password. However, change of authorization is a special Radius feature that adds some more functionality to our network because it allows us to build policies that can dynamically change over our network to things that we set in the policy. Based on the type of connection or the person connecting, we might want to put them into a specific VLAN or have a specific ACL take into effect for that person's network. This would all happen through change of authorization and the policies that we set up in ICE. To show you how this works, we have a couple examples. So this first one is HBS Guest. It is our wireless MAC authentication bypass network. For those of you who don't know, MAC authentication bypass is the idea that we will have people whose devices might not necessarily be registered with our company, but we want to identify those devices by their MAC address, let them authenticate, and then track that device throughout the network. This is perfect for something like a guest network. So we built a guest network with ICE. At the core of this guest network is a Flex ACL that lives on the Flex policies of our access points. And when someone tries to access our open guest network, they're going to hit that policy and they're going to get redirected to a sign-in portal that we built on ICE. And this chart shows how that process works. So you're going to start on that portal and you're going to get the option to register for new credentials or reset them if you already have them. After you register for a new account on our network, you'll get a username and password from ICE. You'll have to accept our acceptable use policy, and then that change of authorization will occur, where your MAC address will be added into what's called an endpoint identity group. That's how ICE tracks your device throughout our network. And then the access points and switches will perform that change of authorization to allow you into our network with some restrictions. Here we have a video to show you how this works. Here I am on my laptop. I'm going to be signing into the HBS guest network. Here I am. This is an open network. My MAC address hasn't been registered yet, so I hit that redirect ACL. It brings me to the HBS guest portal. Here I'm choosing to sign in with new credentials, in this case just HBS test user. ICE is going to ask me for a lot of information. A lot of these fields are optional, but you can specify in your portal policies on ICE which of these you want to make mandatory. And then as soon as I'm done filling out my information, I will register, and ICE gives me a username and password. I will use these to register my device onto the network, and as soon as I hit sign on, my MAC address is not only added to the endpoint identity group, but the change of authorization has occurred, so now I have basic internet access on this network. But we also have a Flex ACL that has happened, so I can access the internet, but I won't be able to access anything internal, such as server addresses, because guest people using our guest network should not be able to access anything internal. So this is an ideal configuration for someone with a guest network like ours.
So I'll be talking about another application of Radius COA here, and that would be a BYOD network. If anybody doesn't know what a BYOD network is, the acronym is bring your own device, but basically what the point is for enterprise network is to allow for employees to be able to bring their own devices to be used onto the network. For this solution, we will be using something similar, and we will be using protocols from 802.1x. One is PEAP, and one is EAP TLS. So the very initial login will require a PEAP connection, which is an encrypted connection to make sure that your credentials aren't leaked for any man-in-the-middle attacks. And then afterwards is an EAP TLS connection, which requires a certificate on the client-side device to make sure that it's basically a key to access the network. And I'll be briefly going over the flow chart over here and how this works. But basically, the first thing it does is it goes and makes sure that you are connecting through PAP, as well as making sure that you're connected to the HBS BYOD network. And then it checks, similar to guest, your MAC address endpoint. If it's not in the endpoint group, it'll redirect you to another redirection page. In this page, you'll have you put in your MAC address as well as the name for the MAC address. So the name is basically just for management, for making sure you can tell who is who and what's for what. Afterwards, it's going to have you download a Cisco Network Assistant. Basically, what this will do is it will install the certificate required for EAP-TLS, and then it will set up the SSID for you. After it's done this, it will trigger a radius COA, or a change of authorization, which basically makes it so you don't have to relog into your network before it goes back to the other policy. And once it makes sure that your endpoint is within the Cisco ICE endpoint group, it'll give you the correct BYOD ACL and access to the network. In this video showing here, we're going to be connecting to your HBS network. During this, afterwards, you'll see a BYOD portal, which was created in Cisco's Portal Builder, which is a pretty convenient way to create portals for Cisco ICE. It's going to have you input your MAC address here, and we're going to put a name for this MAC address for management. And it's going to have you download a Cisco Network Manager. It's going to prompt you here to install as well as accept the certificate for your computer. And it's going to set up the SSID for you. And if we give it a moment here, it's going to set up the SSID and have you re-authenticate with the credentials you previously put in. And then for this ACL, we have it so we can access the IIS, which is a server for sales, but not the rest of the network.
Okay, moving on from BYOD. Identity pre-shared keys, or IPSKs, are more secure than a normal pre-shared key, and it's an ideal solution for devices that do not support 802.1x. IPSK allows devices to be assigned a PSK based off of their identity, which is usually the MAC address of that device. So you can designate thousands of pre-shared keys to devices and groups of devices. This is advantageous because with a normal pre-shared key, if it were to be compromised, you would need to manually re-enter a new key to every single device. But with IPSK, if one PSK were to be compromised, then you will only need to manually re-enter a new key that was assigned to devices using that specific IPSK. So in this video demonstration, we have two devices right here. These are both laptops, both using different MAC addresses, both having different MAC addresses. They're going to be connecting to the exact same network, which is HBS IPSK. For the laptop on the left, I will be using the credential HBS Capstone 2024. That's going to connect me to the network. And then with the laptop on the right, I'm going to be connecting the network using the password test12345. So what we're demonstrating here is two devices. Both have different MAC addresses connected to the exact same network using different pre-shared keys.
So for our disaster recovery, it is important to get our network back up as soon as possible with a minimal amount of downtime. With that being said, it's important for a scope of our network to know where we're recovering. So we're basically recovering any damaged network devices, network configs for our network, and also our server and server VMs. In our DR plan, we also have certain scenarios for any anything that will cause damage to our devices as well, whether it's storm, wind, fire, wire damage, or any ransomware attack, or power surges that could affect our network as well. So we're bringing it back up as soon as possible. And it is also important, if any device is damaged, that we have a replacement up and ready through our supplier via Cisco. And also to recover any lost data or lost configurations, server VMs, and so on, we have an offsite backup to recover from, and uses software called Veeam, which is a very useful software. And to talk a little bit more about Veeam, I'll pass on to Ben.
All right, as Carson stated, we're using Veeam as our backup software. So Veeam is an application that lives on one of our Windows servers that its sole purpose is to back everything up locally. And we are using two backups within our environment, first one being snapshots. Now, a snapshot is a form of an instant backup that takes the current configuration of the VM and stores it locally onto the Veeam server. And it's easy to revert back to a snapshot. All you'd have to do is just go to the snapshot of which you already created, right-click the offending server, and click Restore Snapshot. And what it'll actually do is Veeam will go onto vCenter and delete the offending VM, and then it will recreate the VM from that point of the snapshot. So this is me going through creating another snapshot. So I'll right-click our Nimble there and click Create Snapshot. And the naming scheme that I've chosen is to create the snapshot via the date of which it was created. And as it goes through, it'll look at all the VM configurations and save them. And normally this takes around 15 to 30 seconds within our environment, but it may take longer if you have more data on these servers. And after that completes, I'll close the log out and go to the snapshot. And as you can see, those are the VMs that were snapshotted. And the next backup I'll be talking about is replicas. So it's another form of an instant backup that I have a job that I had running once a week. And what this does is it'll duplicate the current VMs, but instead of saving it onto the Veeam server, it'll save it onto vCenter. So it'll take the name of the server and then put _replica. And to go back to any of these replicas, all you'd have to do is shut down the offending VM and then turn on the replica, and it will go from there. So this is the replica job that I've created within Veeam. Those are the VMs that are part of it. And I'll make my way to vCenter. And as you can see, there's our replica servers, and they are currently powered down. So if we ever want to go back to that replica job, we just have to turn them on. And next I'll be talking about Veeam reporting, which is a separate application that lives on a different server that is connected to our Veeam backup server and takes statistics and whatnot and creates an overall report of this. And it also creates a security risk report. And within Veeam itself, there is an application that runs that compares our overall security of our environment and compares it to best practices. And Veeam takes that data and makes it into a overall fancy report. And it can also do real-time alerting, which if a server were to go down, I think the threshold is 5 minutes, it will email whoever's in that email group about the server going down. And this is the Veeam web portal. I'm just going to open up a random report. This is just a built-in report. You can also make custom reports if you so like to do so. And this is the overall report of it. As you can see, it puts it in a nice layout for easy reading.
All right, now let's talk a little something called dynamic ACLs. So ACLs are obviously rules that you can establish on a network to determine what kind of network activity that you want to allow, restrict, or deny. How these vary is that in ICE, we can actually apply authorization and group policy placements on whatever person that you want to restrict on the network. Let me provide an example. Let's just say that someone by the name of Roger is working in sales. He is put into the Active Directory sales group. On the networking side, he would basically be part of the sales ACL. So in this case, there will be a network, so 10.80 for instance. So whenever Roger logs into his computer, and if he pulled up a command prompt, he would always be on the 10.80 network, no matter what computer he accesses or where he goes on the network. And now we're going to talk about some problems that we've had, as well as the solutions for them. Not every network deployment is going to be perfect. There's obviously going to be tumultuous challenges along the way. So I'm going to start with seizing an FSMO role in Active Directory. So in other words, we were configuring Active Directory certificate services on our network. I accidentally made the mistake of downloading it onto our domain controller, because we then didn't realize this would be a massive issue until we were trying to create an SCEP server, which is basically a server that allows you to quickly send out multiples of certificates across an enterprise level network. And the problem with that is that a domain controller has so many permissions in its user computer settings that you couldn't actually do it. So once you do this, you have to be very careful in how you actually take away the certificate services, because you're basically creating a certificate authority, and that is very messy to clean up. So if you do this incorrectly, and it's very easy to do it incorrectly, you could potentially cause server authentication to fail across all devices, which basically means that your domain controllers are not communicating with one another. And if that's not happening, then no servers are able to communicate whatsoever. So this was on our primary domain controller to make matters worse. And after we'd done this, we then realized that like we had to basically create a third domain controller, power off DC1, and then transfer the FSMO roles, which is the criteria that basically makes a domain controller the primary domain controller, onto DC2. And then once we did this, we were able to get our network back up no problem, and we had no problems with certificates ever since.
Another major issue that we encountered in our project was we were using a virtual wireless controller, and when we had deployed some WLANs, we noticed that our wireless clients were able to authenticate with 802.11, but they weren't able to receive an IP address from our DHCP server or otherwise connect to anything in our network. Real quick, one thing that's interesting about our WLC deployment is in a typical WLC deployment, you would use what's called central switching. That's when you direct all of your client traffic through CapWAP to be centrally switched on the wireless controller. Typically an easy solution, but you only have about 500 megabytes of throughput on a wireless controller doing it that way. So we opted to use Cisco's Flex Connect, which allows you to drop off traffic to be switched onto the local network. It basically means your APs act as trunks and just allow all the VLANs through, drop it off on the local network, and then you get to use the full performance of your local switching environment. It was great for our deployment, but it still wasn't solving this connectivity issue. So ultimately we reached out to some Heartland engineers because, well, they do this for a living and they probably have seen this before. As it turns out, VMware had made a change in ESXi 8 and vSphere 8 where promiscuous mode is no longer turned on by default for port groups. For those of you who are unaware, promiscuous mode is a feature that allows a virtual machine to peer all traffic going across its port group, regardless of whether that traffic is specifically meant for that virtual machine or not. This is super important for a WLC because it uses VMware trunk, which is VLAN 4095, and it needs to be able to see all of that traffic to authenticate and let client traffic through. So once we manually enabled promiscuous mode, we got our connectivity going, and basically the moral of the story is Heartland engineers know what they're doing. They've done this for a living, and I learned a lot from them this summer as an engineering associate, and I'm very honored to be returning this summer as a full-time network engineer for Heartland. So thank you to Heartland. And then also, I'd like to show you guys how much time we spent on this project. We had a cumulative 654 hours spent in person in the lab as a group, with just a little dip there during spring break. So it was a fun ride working with these guys, and we were very appreciative to be able to work on this project.
Yeah, but just be going for over a quick takeaway here. Now, the question is, why do we use Cisco ICE? Why use this Cisco ecosystem for this network? And the key idea is reliability, right? Everybody knows who Cisco is. A lot of the core networking skills people get are from Cisco, like CCNA, CCNP, CCIE. These are certifications that are well known in the environment, and the people who have them know what they're talking about in terms of networking, right? So the idea is reliability. Once you have it set up, we don't assume that it's going to break. It's just going to work, right? Assuming you have it correctly set up, that is. And not only that, it's the accessibility of software, help, and documentation. For us specifically, we're using newer versions of Cisco ICE, newer versions of the VWLC, but there's documentation everywhere. We can find it very easily, and it was something that was very helpful during our time making this. And along with this, we're very thankful for HPS for giving us, a Cisco UCS, the SAN that we're using, the network switches that we're using. These are all things that are much more modern than what we're typically used to working with. And having the opportunity to work with, being able to have a centralized compute storage as well as other things like Veeam, AD, these are all things that we very much needed to work with for enterprise practice. We appreciate the experience because when we go out into the field, these are things that we're going to have to deal with.
All right, and thank you all for listening to our presentation today, and thank you, Heartland, again for sponsoring our overall project. Are there any questions?
So we mainly just use profiling of ICE. We didn't go too deeply into different automations and there are some things that we can do with ICE that would further secure and automate the processes, but we mainly just use profiling of ICE. In terms of business continuity, we are under assumption that when we're recovering from the disaster recovery, that we have business contacts us to reach out for, to obtain UCSs, to obtain switches, network equipment, that these are all things that we'd be able to achieve within a short amount of time. Of course, during the period where these devices need to be transported to us, we need to be able to work at that time, right? So we also have the assumption that off-site we will have backup networking equipment that we can bring on-site or onto a location where everybody's moving, like just in case of a tornado, the office goes down. We'll have a backup location where we can have our devices to be still a working network, basically, to allow for continuity in case of a disaster.
Does it support like other than VMs, you mean? Oh yeah, it'll support Hyper-V and physical servers as well.
Okay, yeah, so basically we don't want to have a bunch of broadcasting SSIDs, right? The benefit of having IPSK is that it's a single SSID and it's all managed centrally. If we have a bunch of SSIDs, you're gonna have situations where, 30 down the line, you're gonna have to go searching for who's connected to where, who's connected to what. But the benefit of IPSK is that it's just one SSID and it's just a centralized location to manage all these MAC address endpoints and devices.
Anyone else? All right.
Hello, everybody. Thank you so much for being patient. I know this is a long day. We are the last presentation, so we're almost out of here. We are Menard's Capstone, and today we're going to talk to you about deploying a multi-vendor network access control with Aruba Clearpass. So I'm Connor Barris. I'm the team lead for this project.
My name's Auvik. I was the firewall engineer for this project. I am Olusegun Joseph Ajibola. I'm the network engineer for this project.
I'm Kenny Lepak. I was the systems engineer.
And I'm Zach Solch. I was the security engineer.
To talk a little bit about our sponsor, Menards, it is the third largest home improvement retailer in the United States and it has around 55,000 employees. We'd like to do a big thank you to Justin Yarrington and Kevin Wagner, who have been mentoring CNIT students over the years and through internships at the Menards corporate office. We appreciate you helping the students learn more about the networking industry, as well as Jason Wers and Tyler Lee, who have helped us technically throughout the project while working with Aruba Clearpass. They have been a massive help when learning this new technology.
Okay, so for today, here's the agenda of everything we're going to be talking about. We have a problem statement. This way, we're going to let you know what we were tasked to do for this entire project, and also what has been our deliverable, the scenarios in which when a device is plugged into the network, what happens. We're going to be talking about that. And also, we're going to be talking about Clearpass. What is Clearpass, and why were we asked to use Clearpass as the platform for this project, and also what has been our takeaways throughout this whole project. And we're going to do a demo, and definitely we're going to be expecting questions from you guys.
So the problems we set out to solve using Clearpass was in a traditional setup, you would have to do a lot of manual configurations, and for every device you wanted to add to a network, you'd have to go in and configure that port or onboard that device. So with our network access control, we set out to automate that process and in effect reducing the manual labor needed to achieve those changes. We wanted to eliminate as much need as possible for communications between departments or users to ask for change to be made. When we also wanted to simplify the process when a device is removed from the network, no one has to go back in and clean that up. And by making all these things easier, we remove friction from the users or interdepartment communication. So it reduces the incentive for things such as shadow IT to show up, meaning that people will start circumventing the usual processes just to get things done faster.
So some of the deliverables and scenarios that Menards tasked us throughout this semester. We'll go in more in depth about some of these later on, but some key points that we won't necessarily touch on in our later demos. One of them being the on-site vendor access. They wanted a solution to have a vendor log into the network with their own credentials, get its proper access into the network. That way they could access their own on-site machinery and Internet of Things devices, as well as dashboards and email alerts. In Aruba Clearpass, they wanted a dashboard that would show what's exactly happening in their network, such as if a device has failed to authenticate when trying to connect to Aruba Clearpass, as well as if a device ends up getting quarantined on our DMZ VLAN, as well as getting email alerts. Getting an email alert when such things such as a failed authentication happens or a quarantine device gets onto the network. They want to get those email alerts to know what's exactly happening on the network.
All right, so throughout this project, we had to prove that Clearpass and the solutions that we were implementing worked between multiple pieces of hardware across different vendors. So a huge thank you to Menards for supplying Juniper and Mist gear that we were able to learn about. Juniper is something that is coming up in the industry, and their AI technology is really cool to see. So getting the opportunity to work with it was really awesome. We also use Cisco and use Cisco APs and a WLC, and our servers were run through HP.
So this is the look of our entire network topology. We have pfSense as a firewall facing the internet to control access into our network and what leaves the network as well. Then we have a core switch. It's a Cisco brand, and that's where we have all our servers. The main server, which is Clearpass server, the CUCM server for VoIP solution, and also for our certificate authority server, as well as our Active Directory server. Then we also have a Juniper switch, which we have a IP camera connected to, as well as the Juniper access point. And also we also have an access switch from Cisco. That's where we have mobile devices for authentication, and also as well as the desktop device.
So some of the different software that we used throughout the semester, we had VMware ESXi as our main hypervisor to house all of our different VMs for our project. We had pfSense, as Joseph said before, as our firewall connecting into the network. That way we could have cloud access through Juniper, as well as having remote access into our environment. We also had Windows Server for our Active Directory and Certificate Authority needs, as well as our DHCP and DNS servers. And then Aruba Clearpass, which is the main point of our presentation today, which I'll hand off to Alec to talk about what more about Clearpass.
Yeah, so before we really touch into what Clearpass is, I want to talk quickly about network access control. Quick question for the crowd. Who feels comfortable having someone walk into their company, connect to the network, and have access to everything? Any hands? One? Yep. Yeah, it's a huge security concern, and you need varying levels of access depending on the user that's coming in. Clearpass really automates that process. So this super simple flowchart we have here kind of shows you the process that goes through when you really just connect in to the network at any port really, which is the beauty of Clearpass. So first it will select a service based on a criteria, based on IETF policies, Cisco attributes, like any vendor really. It's super vendor agnostic, which we'll dive in more. Next, it'll go through authentication, make sure you are who you say you are, look at those credentials, look at the authentication method, and then it'll go into authorization, which is super, super cool with Clearpass because it actually pulls a lot of attributes you can later look at when you are applying roles, enforcement policies, or posturing. Finally, it hits those posturing and rules based on similar things you can set, like with the service selection. In our examples, we have it go against our CA, as well as PEEP credentials and so on that we have with AD. And then finally, you get access. You get put on the correct VLAN, you get the access that you need, and everything flows super quick. It's really nice. But really the root of this is why would you want to choose Clearpass over its competitors, which I'll hand it over to Connor for.
Yeah, so we've heard about ICE in the last group, and now you've heard about Clearpass here. So why should you as a company choose Clearpass? Well, first, it has proven third-party support. We were able to use both Juniper and Cisco efficiently to accomplish our tasks. You could also use Arista. There's so many different options within Clearpass of different vendors. It also has operational simplicity. It's all the stuff is on the taskbar on the left side. You just go through the services, the profiles, and once you start to learn how to use it, it goes really quick. It has a smaller node footprint. Now, taking less space in your data center is huge these days. So Clearpass is just a little bit smaller, and it helps with that. It has superior guest features. With guests getting onto your network, I mean, it can be scary, but with sponsored vendor access like what we focused on, you know who's coming onto your network and you're able to easily track them. It has a better total cost of ownership over 3 to 5 years. So this means you're gonna get more bang for your buck having Clearpass. I mean, that's awesome to see. And one of the main reasons for this is perpetual licensing model. Whoa. You don't see that much anymore. So that's something really cool to see. Once you buy Clearpass, it's yours. So now we're going to move on to some of our challenge and solutions.
One of the challenges that we overcame this semester, I was in charge of creating our certificate authority server in our Active Directory, and I was established to have trust between our certificate authority server and Clearpass Policy Manager. Well, I set up our certificate authority server, I had everything connected and configured, and then I ended up putting the certificate onto the Clearpass Policy Manager in order to establish trust between certificate authority and Clearpass. Well, there wasn't exactly trust between the two of them. It ended up being I ended up rebuilding a certificate authority server, and then I ended up doing one extra check mark box on the certificate authority side, and then we finally got the trust between certificate authority server and Clearpass Policy Manager.
Yeah, so another issue we encountered throughout this project was some stuff with the Stout laptops that we are provided for school and the onboarding Quick Connect client. So Quick Connect is what onboarding users to download, assert, and apply profiles across your devices. And when I was trying to get this to work, I spent 2 weeks just running this profile over and over and over again, and it aired out instantly. I mean, I was digging through Aruba Airhead support and just could not find anything on the errors I was getting. And then my good friend Kenny here tried to get a certificate onto his Ubuntu machine, and it worked instantly. And that was like, I was just like, what? So we tried it on Windows then on an unmanaged device, and it worked like a charm, and we were able to start rolling from there.
Yeah, and the final big challenge that I can say all of us have faced is a lot of the documentation for Clearpass is from Aruba, so it's going to be under the assumption you are using Aruba devices. So really, we had to look for other sources, and luckily with Juniper, they have a whole guide on how to implement different Clearpass stuff, which was super helpful because we could tie that in really well with Cisco devices as well.
So here's our time worked. We hit about 500 hours for this semester. I'm really proud of these guys. We worked hard. There were some ups and downs and some challenges. NAC is a huge product to wrap your head around and can be very intuitive and difficult to start implementing. But I mean, we put our heads to the grindstone and we were able to just get the project done and be efficient.
Yeah, so at the end of the day, this is a class. What are our takeaways from this whole project? The biggest thing is obviously the fundamentals of Clearpass and how NAC tools work. It's really cool to see how it functions, and you can apply it to a large scale enterprise network and really automate a lot of processes to help networking teams work on the things that are very important. Another thing is just the exposure in new technologies. Getting access to Mist and all the Juniper devices really opened the doors of what we learned, because all we really gained was a lot of Cisco ideas that we can apply to further products. And really the last thing, and I would say most important, we really got to work together, and I think we made an incredible team. And this photo here actually was taken when we got the IP camera that you will see later to function when we plugged it into just any port on the switch. And our immediate thought was, we need to get a picture of this. We need to show this off. And yeah, so now we will hop into our live demos. And as we set up, I will talk about our first solution that we worked on. So before I dive into that, I should mention, we don't have someone able to plug in. So we will show you the logs and dive into those attributes. So the first solution is a wired corporate traveling user going from one site to another. They come in and they can just plug in their device and have automatic connection. So if we pop into the wired 802.1x service, you can see that we have the EVPTLS method. What I configured was with EVPTLS, it would give you an employee role. This employee role will give you full access that you can also apply a dynamic ACL to. For our network, we do not have a dynamic ACL because our firewall actually did the routing as well, where we applied certain policies to deny traffic. If you go into the output, we should see that we land in the 150 network, which is our user network. It was really cool. And yeah, I will hand it off to Kenny to now explain the next scenario.
Yeah, so I was, as Connor mentioned before, I had an Ubuntu machine which would talk about the unsupported OS for our scenarios. So why would you not want an unsupported OS to go into your network? Well, unsupported OSs, such as Linux-based machines, have a lot more security hacking tools, such as John the Ripper, which is a password cracking tool that you can use to crack passwords. So we want to keep those devices off of our network. So up here we have under the tips role, like as Alec mentioned before, I have it as not Windows OS, which is showing that it is not Windows-based OS. Somewhere in there too, towards the top of the end host profile, the computer, and then it also says Linux. So it is getting the computer's information from the kernel, and it is knowing that it is a Linux-based OS from the kernel information. Then if you go into the output, radius response, and then private group ID is VLAN 170, which is our guest VLAN, because it puts it onto the network that is least intrusive into the internal network of our system. Now I'll pass it off to Zach to talk about the IP camera.
Yeah, so one of the scenarios we wanted to design for is, what if you had a security camera vendor come onto your site and he's tasked with plugging in his camera to your switch? So traditionally, you'd have to have someone set up the port and then let him know which port to plug into. But with Clearpass, how we have it working is when you plug in any device, we have a DHCP relay that sends a copy of that DHCP request to Clearpass. And with that, it's able to look at the MAC address and the options received, and it matches those attributes to a database within Clearpass. And with that, it can link that to other attributes. So for our Sony IP camera, it was a model it was familiar with. So we can set up a role mapping to match any device that's registered as a Sony IP camera to the IP camera role. And with that, we are able to apply a profile and have that applied to a switch port that is automatically set to that camera VLAN. And for this scenario, we're considering devices that aren't capable of .1x security. So we're using MAC address authentication bypass. So it's a little bit better than just regular MAC authentication in that it is also considering the fingerprinting. So in order for someone to spoof something like that, you'd have to mimic the MAC address and the DHCP options being sent. It's possible it could be done, but it would end up on the VLAN that you have a set for that device to go to. So it'd be isolated there. And with that, I'll hand it off to Joseph to talk about our IP phones.
For the VoIP solution aspect of this project, I used Cisco Unified Communication Manager, and we are tasked with a scenario whereby an IP phone is plugged into the network. Normally, it will join the voice VLAN, and also to dynamically connect a PC that is plugged behind the IP phone to join the data VLAN. And that's what I was able to do. And so when an IP phone is plugged into the network, also just like for the IP camera, it also uses MAC authentication bypass method to connect to the network. And so it's used after the IP phone is authenticated and it's joined the voice VLAN. The PC that is plugged behind it also automatically joined data VLAN, which is our user VLAN. And the PC itself uses TLS, while the IP phone uses MAC authentication bypass. And okay, for the input, we could see the private group ID 130. That's our voice VLAN. And also, if you click on the output, the output tab, yeah. Okay, so sorry, the output, yeah, the group ID is 130. If you go to the input and go to the endpoint attribute on the input, the endpoint attribute. Okay, the endpoint attribute is showing the IP address of the IP phone, which is the voice VLAN, and also it's showing the category of the device as a VoIP device. And also we could see under the fingerprint details, we have the DHCP options, 150 configured on it, whereby the phone was able to connect to the CUCM server to derive the firmware for it to be registered on Cisco. And also, if you go to click on the endpoint, yeah. Then please go back to the input and click on the endpoint attribute to close it. Under the computed attribute, Okay, so we see the authentication method and the source of the authentication using MAC authentication as and also MAB, and giving us the details of the device that is plugged to the network. And also, if you go to the search for go back to the tracker, access tracker, and let's see how the PC that was plugged behind the IP phone was able to also get authenticated. If you scroll down, you see. Okay, that's this one. Yeah. Okay, so if you go to the output first, yeah, we could see that the PC here also joined the other VLAN 150, and on the input, you will see the authentication method. It uses EVPN on the input. Okay, computed attributes. Okay, so the authentication method is showing EVPLS. So I pass it over to Connor.
All right. Yeah. So now I am going to go over BYOD. So, like the last group, we implemented a BYOD solution. This is Aruba Clearpass onboarding. Something a little bit different that I did compared to the other group was we're using dual SSID BYOD. So instead of just using one BYOD SSID, we're going to connect to what I have named vendor, but it could be guest, and then get put onto the employee network. So I'm going to run this video here. You can see we have no internet connection right off the bat. And then once we go, we're going to connect to what is Menard's vendor here. This could be, like I said, your guest network. And we're going to try to connect here. So it's going to hit a redirect because it's not a known device in our endpoints or in our it doesn't have a certificate. So here we come up here to this page, and at the bottom it says, "Are you an employee? Onboard." So this is going to bring us to the web authentication of the onboarding process. You sign in with your AD credentials, and I think, yeah, I had to mess up my password for realism here. And there we go. Now it's going to ask you to start the Quick Connect client, and this will download this client onto your PC, and it's going to be what puts the enforcement policies and the certificate onto the device. So I'm going to wait, let it run. This computer is not new, so it is going to take a little bit. And smart screen, Windows doesn't like that it can't reach out to the internet, and it's downloading something. And there it is in 1 second. Boom, Quick Connect. Awesome. So here's the welcome page. We're going to go next, and then it's going to start configuring the SSID that is the employee SSID. And at the same time, it's going to be installing a certificate onto the device. So you're going to get a pop-up, says, do you trust the certificate authority? Do you want to download the certificate? Yeah, we do. I want to get onto this network. So now you can see the Menards employee SSID is built, and we're going to connect to it. It's going to try to go through the radius request through EVPLS. And through Windows, you have to go in and hit connect because Windows doesn't like this. But once you do, you can pull an address from the employee network, and your device is onboarded onto the employee network. So we're going to go back, and we're going to look at Clearpass and some of the access trackers. So first is the onboarding section of Clearpass. You're going to see here, this is where you can tell where a user is. From here, you can revoke a certificate, and it will kick them off the network using OCSP. Here's some of the attributes that are created from it. So it first goes through the web auth, then it goes through the provisioning in which it downloads, and that's the service that enforces the download of the certificate and the client. And then it goes through the radius request, in which that is what's looking at the certificate that you got, and it's going to let you onto the network. So that is it for onboarding. Now we will bring it to questions. So I can let Alec look at this, talk about this, because he actually looked at this through Clearpass.
Yeah, so when I was originally doing it, I was going to create a NAP policy. I found out that our PCs don't support that, but I did look into opportunities. Clearpass is really cool. It has an application you can download and even push the download within the onboarding service that will actually check, do you have these apps? Do you have this version of a firewall on your computer? It's really cool, and it will give out an input based on how many checks it passes. So there is healthy, there's quarantine, there's failed, and there's unknown. Right now, all of ours are unknown just because we can't posture them, but it is a possibility. I believe it's just at login, and I would assume every time it boots up, it'll check that again. Yeah. Yep.
Yeah, so everything was just on our premises. This was basically just a proof of concept that it would work. We didn't really look into anything how it would work with off-prem, just because it's not something that we had to really look into. So yeah, unfortunately, wouldn't be able to answer that question. But
Yeah, so what it was, we have dynamic ACLs that apply. It initially actually goes on our quarantine DMZ, which is only allowed to communicate those things with Clearpass. And then after that, it will apply it to the correct VLAN based on the attributes it gets, and it will just be put on that VLAN on the firewall to communicate. The ACL itself just wasn't needed in this scenario. Any other questions? All right.
thank you everybody for watching. We really appreciate your time, not just myself, but every Capstone student here. Just a reminder, we will be heading to 6th Avenue Cidery for a networking event after this. There's a map up here, and this is what the building looks like. So yeah, we'd really appreciate seeing you there. Thank you.